everyone, I'm Liz Walls, lead developer of the Continuum Wind Energy software and director of renewable energy services at One Energy Analytics. And today I'll be going over how to conduct MCP, or Measure-Correlate-Predict, in Continuum. MCP is a technique widely used in wind resource assessment, and it's when you have a shorter-term data set measured at what we call a target met site location, and then correlate it with some long-term reference. And then, based on the relationship formed between the two, you can then predict the long-term wind speed at the target location. Okay, let's take a look at how we do this in Continuum. Okay, so I've just opened up Continuum, and the first thing we want to do is save the file somewhere. So I'll save it on my desktop. We'll call it MCP demo. You always want to save your file since Continuum creates a local database file to store a lot of the information used in the Continuum model, and it needs to know where to save that database. So make sure to save your .cfm file. Once that's done, you'll need to then import some metadata. So recall that the metadata has to be formatted, the headers have to be formatted in a particular way for Continuum. So for more information on that, check out the video, How to Format Metadata Time Series. So I'll click this button, Import Metadata. It'll ask me if I want to apply filters, we'll say yes. Asks me about the modeled height of 80 meters, say yes to that as well. And then it's going to ask you if the metadata timestamps are shown in local time. Keep in mind that the reference data, when downloaded, will get converted to local time based on the UTC offset calculated by the coordinates in your metadata file. So for this demo, the data that I'm using is in local time, so I'll click yes. And then I'll find that file and bring it in. It'll ask you for the datum. So that's the first one there, the typical NAD83 WGS84 datum, and then the hemisphere, northern and southern. I'm in the US, so I'll click northern and click OK, and then that will start the metadata import. Okay, now the data has been read in. The next step is to add some long-term reference sites. So we're going to go to the long-term reference data tab. The first thing we need to do is create those links between our Continuum model and the folders where the long-term reference data exists. For more information on that, check out the video, How to Download Reanalysis Data. So I'm going to link up to my folder that has Mira2 data. So I'm going to click Select Folder, go to my desktop, and there's my Mira2 data that I have stored on the desktop. That shows the data range contained in the folder. That looks like it covers the time that I need, so I'm just going to click Add. And actually, let's do one more. Let's add some ERA5 data as well. So I click this button again, and it will open up the Download Reanalysis Data. So there's the Mira data that we've already added, so I want to click a new one. Don't need to specify the type, it'll figure it out on its own. Just have to click Select Folder, go to the folder, there's my ERA5 data, and I'll click OK. Great, and there's the data range for the ERA5 data and the latitude longitude range contained in those files. So that all looks good, don't need to change anything, I'll just click Add. And so what that did, it just created the links between, again, this Continuum file and where the reference data downloads are. So now that's done, now we can actually define some long-term reference sites. So to do that, we click New, opens up this form here, and this is where we can choose either to pull from the Mira2 folder or from ERA5. We'll do both, so I'll start with ERA5. Here's the demo met site that we've entered, and it has read in the coordinates, so we don't need to enter that. That's all done for us. But I am going to change the end date so that we have full years of data. And I'll use just the closest node. You can choose 4 or 16 and do an interpolation between reference nodes, but we'll just choose one for this demo. And I'll click OK. And then that will start the ERA5 data import. And once the ERA5 data has finished being extracted from the reference data folder, all the tables and plots will populate on the long-term reference data tab. And let's go ahead and add another one. So we'll also add a Mira2 data at the same location. So I'm going to select from the Mira2 from the list of reference data downloads. Again, it has the coordinates. It's going to automatically choose the same start end date as the other reference site. So we'll just click OK to now add that Mira data. Okay, so the Mira2 data has finished importing, so now let's head to the MCP tab. So first of all, on this tab in the top left, you'll have this drop-down menu which will show you all the Met sites currently loaded in the software. At the moment we just have the single Met tower that we've called Demo Met Site. And then the second drop-down menu will show you all the long-term references defined for the selected target met. So we've defined one using ERA 5 data and one using Mirror 2. Keep in mind that ERA 5 and Mirror 2 data are hourly reanalysis data sets. And so when 10-minute met data is imported into Continuum, it actually gets automatically converted to hourly data to Conduct MCP. If you click this button, it will remind you of that fact that we're using hourly data for MCP. Okay, moving over now to the right-hand side of the tab, this is where we can select from the 4 different MCP methods available in Continuum. Those include orthogonal regression, method of bins, variance ratio, and matrix. I'll be doing another video down the road that really dives into the theory behind these 4 models, but it's outside the scope of this video. Okay, so once you've selected your method, there are then some bins that you can set. So first of all, you can specify the number of wind direction bins that the data will get divided into before conducting MCP. And the number of bins can range from 1 up to 24. It is set to 16 by default. Next, you can specify time of day bins. It can be either 1 or 2. If it's set to 2, then it will further divide the data into daytime and nighttime, where the daytime is defined as all time between 7 a.m. and 6 p.m. and the opposite for nighttime. Next, you can also specify seasonal bins between 1 or 4, 4 being obviously winter, spring, summer, and fall. If you're using either the method of bins or the matrix setting, then you can change the wind speed bin width. By default is 1 meter per second. And if you're using the matrix method, then there are these 2 weights that can be applied. And again, I'll be doing another video that dives into the theory that will explain what those weights actually do. Once you've selected your target met and the long-term reference and selected the MCP method and all the bin settings, go ahead and click the button Do MCP. If you have several met sites which all use the same long-term reference, you can click Do MCP at all mets to save a few clicks. When it's finished, the scatter plot will populate as well as the text boxes showing the concurrent and long-term wind speeds at the reference and target site. An MCP estimate will be generated at each anemometer level, as well as at the modeled height of 80 meters in this case. The scatter plot corresponding to each height can be viewed by changing the height in this drop-down, and the other drop-down menus allow you to view the scatter plots in the various wind direction, time of day, and seasonal bins. So for example, we'll look at some directional bins, and you can hover or scroll through those to see how the relationships change. Set that back to overall. And these text boxes up here show the average long-term wind speed at the target site here in the middle, as well as the average concurrent at the target site, and then the average wind speeds, both concurrent and long-term at the reference site. If you're using orthogonal regression or the variance ratio method, after you conduct MCP, then you'll see these text boxes, the regression statistics show up here. So they're showing the slope and intercept as well as the coefficient of determination R squared for that best fit line. If you use the method of bins method, so let's go ahead and do that. So I'm going to change the method, and it's going to warn me that I'll clear all settings. I'll say that's okay, I want to continue. So I've selected the method of bins method, and when we do this type, then we'll see this table populate with the average wind speed and the average ratio between the target and reference site. And then on the scatter plot, you'll see these boxes, and those show the average ratio in each wind speed bin. There is also an MCP uncertainty analysis tool built into this tab. And to run this, just click the button Do MCP Uncertainty Analysis. And this will kick off some calculations happening in the background where the target met dataset is sliced into subsets of data, and MCP is conducted using those subsets or windows. It starts with a window size of 1 month and conducts MCP using every monthly period in that dataset. It then increases the window size to a size of 2 months and conducts MCP using every 2-month period. This continues up to a window size equal to 1 month shorter than the MET dataset. The results show how much the long-term estimated wind speed varies within each window size, and it also provides insight into the uncertainty of the MCP estimate. This setting here, the uncertainty window set, is set to 1 month. And what that tells Continuum is to move those windows along in 1 month increments. So if you have a very long data set, the calculations could take a little bit of time. So to increase or to speed up the calculations, you can change that step size up to 4 months. So it just moves the window in 4 month increments instead of 1. And finally, there are a few export options on this tab to go over. First, you can export the hourly target data by clicking this button down here, which will export all hourly wind speed and wind direction data at the target site. Recall the Continuum automatically converts any 10-minute met data to hourly when conducting MCP. Users can also export the long-term estimated time series data by clicking this button. And the long-term estimates can be exported as a tab file by clicking this button. And this is really helpful if you have a site with several met towers and you want to generate a wind flow model. So in those cases, I would often do MCP for each met tower, export the tab files, and then create a new Continuum project to do the wind flow model using the tab files, which are a little easier to work with than the time series data. Next, you can also export the uncertainty analysis results by clicking this button. And then lastly, if you've conducted method of bins MCP, then you can also export the average ratios within each bin. All right, that covers all the aspects of the MCP tab. I hope that this was a helpful tutorial. But if there are any questions or comments, feel free to comment on this video or send us a message through the website contact form. All right, thanks so much everyone, and take care.